So, arithmetic progressions. Arithmetic progressions for sequences. Well, they have the following in common. I'll give you an example. 5, 9, 13, 17. From one term to the next, I'm simply adding 4. So we have a first term, we call that A. A second term comes by adding our common difference to our first term. The third term comes from adding 2 common differences to our first term, and so on. So if you notice, I'll just write 1 for the first term, 2 for the second, 3 for the third, 4 for the fourth. And you'll notice that hopefully that the number of differences is 1 behind the term, because the first term in the sequence has no difference. So when we ask for the nth term, the most common mistake we get is a student will think that it's A plus ND. In fact, it can't be that, because the difference is always lags 1 behind the term. So again, just to repeat that, the first term has no difference in it. So if I put 1 in here to get the first term, our first term would be A plus 1 take 1 times D. And that equals A times 0D, which is A. My second term would be A plus 2 minus 1 using the formula D, which is A plus D, and so on. So it's important to remember that. So if I was going to write the nth term of this particular sequence, then I can do it, because I know that in this sequence that A is 5 and that D is 4. So the formula then for the nth term is A plus n minus 1 D, and I have all the values that I need. So A is going to be 5, or is 5 should I say, plus 4 lots of, we'll write the 4 around the front, n minus 1. Now the nth term will be in terms of n, but it will be 5 plus 4n minus 4, so it ends up as 4n plus 1. So that's an important term. I'll show you why. So I'll write out the terms again: 5, 9, 13, 17, 21. So if I wanted the value of the fifth term, 1, 2, 3, 4, 5, so the fifth term's value can be found by using the formula. So if I substitute 5 in for n, I'll have 4 5s, which are 20, and 1, which is 21. So this little formula generates any value of the term, provided I know its position. So if I wanted to know what was the 30th term, I wouldn't have to write out all 30 terms. It would take some time. I simply substitute 40 into here. The value of the 40th term will be 4 times 30 plus 1. That would be 121. So this is a powerful little formula, and that's the sort of start, if you like, to arithmetic progressions. I think what I can do is go on and show you the next key formula using this example all the way through. Now, it might be that we want to add up a certain number of terms, and we can do this using this formula. Sum of n terms, an arithmetic progression, is n divided by 2 times the first term plus the last. So the sum of these 5 numbers then in our arithmetic progression, we can plug this in. The sum of 5 terms, sum of the 5 terms, will be 5 divided by 2 times the first term, which is 5, plus the last term, which is 21. Now that's going to be 5 over 2 times 26, and that 2 will go into 26 13 times, and 5 13s, and 5 10s are 50, and 5 3s, 15 is 65. And you'll see that that will correspond to this, that 14 and 13 is 27, and 17, 40. 4 and 21 is 65. So although you might think, well, I could have added those 5 numbers up quite easily, what if I said to you, what's the sum of 30 terms? we could have done that like this. We could say, okay, it's 30 over 2, 15, 5 plus the last term. Now the last term is the nth term. And we have the formula for that, which was 4n plus 1. And you remember that that was 30th term, so it's 120 plus 1, 121. So we can then move this to 15 times 5 plus 121. So that becomes 126 times 15. And I can quickly do that with, well, you're not allowed to calculate actually in the C1 exam. So we'll do 6 fives are 30, 2 fives are 10, 3, 13, 1 5 is 5, and 1 6 is 30. 0 there, 1, 2, 6. And you can see that I have got the sum of the first 30 terms at 1,890. So that's therefore the use of the sum of n terms and the formulas that go with it in this first part of arithmetic progressions.